anytime you're asked to find the relative extrema of a function, it's that same mantra. Set the derivative equal to 0 and solve for x. So we are going to, on this function, we're going to take the derivative of f of x. We'll get f prime of x. The derivative of that first term is 1/2. The derivative of the second term is negative cosine of x. We will set that equal to 0 to find our critical numbers. Add cosine of x to the other side. We're asking for values of x between 0 and pi over 2. So that's going to be pi over 3 and 5 pi over 3. Those are the two values between 0 and pi over 2 whose cosine equals 1/2. So these are potential places where relative extrema may happen. So to verify what type they are, or to determine, I guess, what type they are, make your f prime line. Try that again. And I always like to label this. So sometimes we have an f double prime line, or maybe it's a velocity and acceleration line. So make sure you label it so we know what we're looking at. And we've got the smaller one on the left, and the larger one on the right. And we pick some test values, right? These are values where the derivative equals 0. And now we're going to ask what happens to the derivative when we have a test value of, say, 0, or perhaps pi, or perhaps 2 pi. Pick easy ones to work with. Why make things harder than they need to be? Cosine of 0 is 1. 1/2 minus 1 is negative. Cosine of pi is negative 1. 1/2 minus negative 1 is positive. 2 pi, same as 0, give us a negative. So we see that our function is decreasing until we get to pi over 3, and then it's increasing until we get to 5 pi over 3, and then it's decreasing again. So we can say that f of x has a relative decrease to increase would be a minimum of f of pi over 3, which equals, let's see, pi over 6 minus the sine of pi over 3 is root 3 over 2. That is a relative minimum because f prime changes from negative to positive at x equals pi over 3. Again, every single time. It's that same routine answer every single time. Don't make it any messier than that. And then same idea, f of x has a relative maximum of f of 5 pi over 3, which is 5 pi over 6. That's when you multiply it by 1/2, 5 pi over 6. And then sine of 5 pi over 3 is negative root 3 over 2, so when you subtract, you get a plus root 3 over 2. And the reason that's the relative maximum, because f prime changes from positive to negative at that x value. 5 pi over 3. All right, and that's how you should write your answers. All right, we'll try another one, see how it goes. Same idea. Take the derivative, set it equal to 0. And we get 2/3. The argument of x squared minus 64 doesn't change. We subtract 1 from the exponent to get negative 1/3. And then multiply by the derivative of the argument, which is 2x. I'm going to go ahead and clean this up a bit. We have 2 times 2 is 4. We have an x. That's what's in the numerator. And we've got a 3 times the cube root of x squared minus 64 in the denominator. So my mantra is take the derivative and set it equal to 0. And when I say it, I really mean either the numerator or the denominator, because remember that critical numbers occur not only when the derivative is 0, but also when the derivative is undefined. So we will look at the numerator of 4x equal to 0. We will also look at the denominator of 3 times the cube root of x squared minus 64. Set that equal to 0. So we get x equals 0 for this. We've got x equals plus or minus 8 for this. And those are our three critical numbers. Notice that even though 8 and negative 8 cause the first derivative to be undefined, because it gives us a 0 in the denominator, 8 and negative 8 are not undefined x values but they don't cause y to be undefined for the original function, right? Because when we get 0 raised to the 2/3 power, nothing breaks. We're allowed to take the cube root of 0. We're allowed to square 0. So this function is continuous over all real numbers. But it is not differentiable over all real numbers. But that doesn't mean anything about these values. We still want to include those. We want to make sure that we are considering all of our critical numbers. So both the numerator and the denominator are set equal to 0. When we investigate our f prime line, we put negative 8 on the left, we put 0 in the middle, we put 8 on the right. And these are places where either the derivative is equal to 0 or it's equal to undefined. So I put little u's there for undefined. And then I do some test points. Maybe I'll try negative 10. And I'm checking not in the original function. People always ask, which one am I plugging it into? Well, this is an f prime line. So plug this negative 10 into the f prime function. Right? We're asking, what is the derivative doing here? I don't particularly care what the y value is there. I care what the derivative is doing. And we've got 2/3, which is positive. So well, actually, let's look at the fraction. We've got 4x, which will be negative 40. So negative on the top. And then inside the radical down here, we've got negative 10 times another negative 10. That's going to give us a positive 100 minus 64 is positive. Cube root stays positive times 3 stays positive. So negative 10 puts us negative in the numerator, positive in the denominator, so that's going to be a negative answer. Between negative 8 and 0, I like negative 1. That's a pretty easy number to work with. Numerator is still negative on the top, but if we put negative 1 in here, we have 1 minus 64, which is negative. The cube root of a negative number is negative, and 3 times a negative number is negative. So we have a negative over a negative, which is going to give us a positive, and then we just keep on trucking along. 1 is going to give us a positive on the top, but still a negative on the bottom. So that's going to be negative. And 10, for example, is going to give us a positive on the top and a positive on the bottom. So that's going to give us a positive. So we actually have 3 different places where our function changes from increasing to decreasing or decreasing to increasing. We have 3 different places where the derivative changes signs. So let's determine which one's which. We've got let's see, decreasing, then increasing, then decreasing, then increasing. So we've got two minimums. F of x has relative mins, plural, not at. Of is the value, at is the location. So I want to say the y values are the actual minimums. F equals plus or minus 8. And it turns out in this particular case, whether we use positive or negative 8, we're getting the same answer. These two values don't have to be the same. Our two relative minimums could be have different y values, but in this case, they're the same. Has relative minimums of 0 because f prime changes signs, changes from negative to positive. At x equals 8 and also x equals negative 8. So we can just say plus or minus 8 because of the symmetry here. And then finally, we've got f of x has a relative max of f of 0, which equals, well, we're going to plug in a 0 here. 0 minus 64 is negative 64. Take the cube root first. That'll give us negative 4. And squaring negative 4 is going to give us positive 16. Okay, and that's good that if we have a y value of 0 and we're increasing, we're going to get to something positive. So that makes sense. And then we're going to decrease from 16 back down to 0 to get to that next relative minimum. And the reason this is a relative maximum is because f prime changes from positive to negative at x equals 0.